Welcome back to Cerebri Learning and the second episode of our Introduction to Physics series. Today's lesson is on introductory kinematics and 2D motion. For those of you who may or may not have seen our last video on physics, let's recap. Physics is the study of matter, energy, and their interactions. Sometimes these interactions come in the form of motion. This brings us around to the discipline of mechanics, which is the study of motion. This is further broken up into dynamics, which are the causes of motion, and kinematics, which describe motion. Alright, you're up to speed. To start off, we're going to be discussing what motion is. Motion is a change in position over time. The simplest form of motion can be described in two directions. These are the positive and negative directions. When you describe a positive velocity, that is the speed something is traveling at in the positive direction. In the same way, positions can be positive or negative. We are going to take a look at a few graphs to help describe these phenomena. These graphs concern a car accelerating at a rate of 5 meters per second for 10 seconds, starting at an initial velocity of 0 meters per second. We will start with the acceleration graph. It is a constant line at 5 meters per second for 10 seconds. The equation of the line is acceleration equals 5. There is no input value because the acceleration is constant at 5 meters per second for 10 seconds. The velocity graph is a y equals mx plus b graph. The equation is velocity equals 5t. You'll note that the rate of change of the velocity graph is the value of the acceleration. The position graph is a quadratic function. This position changes more rapidly as the velocity increases. The position is 1/2 5 squared plus whatever the initial velocity times time is, plus whatever the initial position is. In this case, those can be both ignored since the initial velocity and initial position are 0. If the car was braking at 5 meters per second for 10 seconds with an initial velocity of 50 meters per second, the graphs would look like they had been reflected over the x-axis. The acceleration graph would have an equation of y equals -5. The velocity graph would start at 50 and would decrease to 0 with the equation velocity equals -5t plus 50, where t stands for time in seconds. The position graph will look reflected from the last position graph. It would initially increase rapidly, but the increase would slow as the car's velocity decreases. There's a clear relationship between these graphs. In this scenario, the acceleration graph is constant, the velocity graph is linear, and the position graph is quadratic. This is simply due to the fact that the rate of change of the velocity graph is acceleration, and the rate of change of position is velocity. It's a cascade effect. As velocity increases because of the acceleration, position also increases, but at a higher rate than velocity. Thank you for watching this video. We here at Cerebri Learning would like to thank our sources, 2D Motion by Frewin and Graphing Motion by gpb.org. Our full bibliography is in the description as always. Thank you.